So now it's time for us to talk about the next case study, part 2 of case study ex2. And this is going to demonstrate some other features we didn't talk about before, like block optional and so on, and on error resume, where once again we're going to create, reduce, multiply, and display big fraction objects asynchronously. And we're going to show how you can handle runtime exceptions in this context as well. As before, we're going to show both fully asynchronous and hybrid synchronous asynchronous models to demonstrate how these different features can be applied in combination. And you can go and take a look at the ex2 folder to find this particular example. So we're now back in my IntelliJ project for the ex2 case study. Let's go ahead and take a look at the ex2 case study driver. We looked at this before. It's got a bunch of registrations of test methods. We're going to focus on the ones here, these 3 final ones. As we always do, they're all going to be running asynchronously in the context of the async task barrier, and then the main thread will block until they're done, in which case we'll find out how many completed successfully. Let's go over here to mono ex, and you can see that what we're going to do here is start talking about test fraction multiplication callable 1, which is a bit of a mouthful, but it's basically what this is demonstrating. This particular example is going to have all the string manipulation and appending done in one thread, so we can use a string builder again. And what we're going to do here is we're going to use the from callable method, passing in the scall field. Scall is a callable that takes 2 big fractions and multiplies them. And we're going to arrange to run this in the background. So it's going to run in a single background thread. And then we're going to use the block optional method to wait. So that'll cause the calling thread to wait for the asynchronous computation to run to do the multiplications in the background. And when we're all done, if it goes well, then we've got an actual optional present. So we'll say result.map, which will convert the multiplied big fraction into a mixed string, or else we'll just print out error. We then display the results and return s void m because we're done. So that's, again, basically a synchronous conclusion to a method that was hybrid synchronous and asynchronous. Now let's go take a look at test fraction multiplication callable 2. This also does the same thing. It starts the call in the background, runs it in the background thread, but this time we don't have any blocking to get the results, either block or block optional. All we're going to do is run everything in the background thread, and now we're going to use .then to indicate that this computation is finished, running asynchronously, and that is an indication to the async task barrier that we're done, and it can check to see if anything else is still running, and if not, it'll return. So very, very similar, just we're not blocking the calling thread at all. And then the final method here is called test fraction multiplication error handling, and that's exactly what it's going to do. It uses a string buffer because it's going to do things in different threads. And this is kind of fun. Check this out. So we're going to make a callable, and the name of the callable variable is bad call. And we're not talking about an umpire at a baseball game making a bad call. We're going to have a call that's actually going to fail. And the way we make this fail is we create ourselves a numerator. So we create the numerator. Let's say create a valid numerator. And then we're going to create an invalid denominator. So the denominator is invalid. And the reason it's invalid, as you can see, is we're giving it the value 0. And anytime you take a numerator and divide it by a 0 denominator, bad things happen. It's a bad call. And specifically what's going to happen here is that's going to throw arithmetic exception. Anytime you divide by 0, you get the arithmetic exception. We then define ourselves a function, which we're going to call error handler. And the error handler function object will take a throwable, which is whatever exception has occurred, and basically a mono, which extends big fraction, which is going to indicate the return value. And what we do here, in this particular case, whatever exception occurs, we're going to print the name of the exception by appending it to the string builder, and then we're just going to return 0. No matter what has happened, we're going to return 0. If we wanted to be a bit more discriminating, we could have done some kind of check to see if the throwable parameter was in fact an arithmetic exception, or if it was a different exception, like a null pointer exception, we could do different things. But in this case, we just log what's happened, and we just convert the error to 0. So you can see what we do is we say mono.just big fraction 0. A 0 comes back no matter what exception was thrown. So then here's the actual call. We're going to say mono from callable bad call, like bad dog. And that will then, of course, trigger that exception. We're going to run this in the background. So any exception handling we do has got to be handled in the appropriate context, which will be a background thread context. And the way we do that is by using onErrorResume, passing in the error handler. You can see the error handler up here. And what that'll do is that will convert the arithmetic exception to 0. And then we print that result and we return an empty mono to indicate we're done. So let's go over here and look at the run output. Remember, these were the methods we were doing. So test fraction multiplication callable 1. That just does callable in, gets the result back in the main thread, because remember it used blocking optional. So it was blocking for the asynchronous computation to finish. Test fraction multiplication callable 2 was running in a background thread. So you can see here that it's got background computation. And then the final thing here, which also ran in the background thread, got the divide by 0 exception, arithmetic exception, and converted the result to a 0. And that also takes place in a background thread. So that's the second example. And hopefully you now have a better idea of how to run computations asynchronously by using subscribe on. We will see that subscribe on also is used with fluxes to get much the same behavior. It runs things in a different computational context.